Hi folks, it's Mr. Defy once again. This is a continuation of my previous video in which I ran out of time to give you my last example. This is the example that I ended with, so I want to pick it up from here and just make the connection to that last video. In this example, we looked at how to graph a line from a function that's in point-slope form. In this example, my last one, we're going to write the function of a line based on a graph that we can see. So we don't have to make the graph this time. It's already been done. We have to simply come up with the name of this line. And it's different from the last example in that in example 3, you had the name of the function, but you didn't have the graph. And so you had to make the graph based on the function. Whereas here, we have the graph, but we don't have the name of that graph. So this time we have to actually work backwards and generate that name. But it's real simple to do. So first, like always, let's start with a blank equation. So it's y minus y sub 1 equals m multiplied by x minus x sub 1. And just a quick reminder again, this is the slope, so we will need that number, and I'm going to correct that letter to make it look like the letter E. There it is. So we will need the slope. We will also need an input value, or our x value. And here we will need an output. Okay? So my x and y, my x sub 1, y sub 1, those represent a single ordered pair together. And so if you look at this graph, I actually am given many ordered pairs to choose from. But there are two that are already marked. So I'm going to go ahead and put the location of these two ordered pairs. And I'll choose a better color here. So the first order pair we have is located at 1 and negative 3. The other one over here is at negative 3 and it looks like it's at 2. Negative 3 comma 2. So which one do we use? Well, the answer is that we could use whichever one you want and whichever one you feel most comfortable with. It really is up to you. But you have to choose one and use it. So no matter which one you use, know this. They each have an x and y. Okay? And depending on which order pair you choose, the number for x and the number for y will be placed into these two locations. So I'm looking at this one here. Okay, that will be the y value, the y coordinate from whichever point you choose, and this will be the x coordinate from whichever point you choose. Okay, so let's go ahead and make our choice right now. So let's see, it doesn't matter to me. I'll choose the first one that I wrote, which is this one here, 1 and negative 3. Again, you could have chosen this one and it would be perfectly fine. They both lie on the same line, so it's like a brother and sister belonging to the same family. Okay, doesn't matter which one, they're both part of the same. So I'll choose 1 and negative 3, and what that means is that I get a function looking like this. Y minus. Now, the y sub 1, my input, is going to be the y coordinate of the point I chose. Now, I chose a coordinate with a y coordinate. I chose an ordered pair with a y coordinate of negative 3. What this means is that this negative 3 will take the place of this spot here. And I'd have to show that what I'm inputting, what I'm putting into that spot is a negative number. So I use parentheses to show that it's y minus the negative 3. Okay, if you just put y minus 3, that wouldn't be correct. It would mean something else. Okay, then I have m x minus. Now, my input number, my x sub 1, that will come from the same order pair. And as you can see here, my x value is a 1. So that will go in place of this. And now I have x minus 1. Now, it looks like we're done, but we're not, because we need the slope. And I don't have that yet. But fortunately, it's real simple to get from looking at the graph. And there are two ways to get it, and I'll show you both. One way is by simply counting the squares and getting the slope like that. If you remember from my last video, it does help to sometimes calculate the slope because, believe it or not, in counting and transferring the slope, we can make a mistake. So I'll do it both ways anyway. Here it is. If I were to go from here down to the next point, which is over here, to get there, I'd have to count 1, 2, 3, 4, 5. So that's 5 down, right? That means it's a -5 because I went in the downward direction. Then I would go 1, 2, 3, 4 to the right. Because I'm going to the right 4 times, going to the right is a positive direction. This is a positive 4. Therefore, my slope would be, and we could go ahead and finish this right now. This would be a -5 over a positive 4 times x minus 1. And I should have noted earlier that this is a double negative. And as always, we must change that into a positive. So the final answer would be y plus 3 is equal to -5 over 4 times x minus 1. Now this is the end. But I did say that I want to show you another way to get the slope. And it is review of how to get slope in the first place from looking at a graph or from just 2 points that you know lie on a graph. And very quickly, this is the way that it would go. So if you wanted to get the slope by calculating it, it would be change in y over change in x. You choose where you want to begin. Doesn't really matter, but you have to choose somewhere. I'll go left to right, which means that I will start with a y coordinate of 2, and that will change into a -3. With my changes in x, I will start with the -3, and that will change into a 1. Once again, we have a double negative here. That becomes a positive. I rewrite it, and I get 2 plus 3 over -4, which then becomes 5 over -4. And if you're thinking, well, Mr. D, that 5 over -4, that's not the same as -5 over 4. But it is. And the reason why it is because that negative belongs to the entire fraction. And because a fraction is made up of 2 numbers, a numerator and a denominator, it really doesn't matter where the negative sits because it still makes the entire fraction a negative. So whether it's -5 over 4 or 5 over -4, they mean the same thing. Okay? And you can put that into your function and it will mean the same thing. So there is a function. I do want to end it with saying that this function would look different had we not chosen the 1, -3. So what I mean by that is if we had chosen the -3 and 2 instead, then my function would look different, but it would mean the same thing. So let me go ahead and finish this off with that alternative ending here. So if we had chosen -3, 2 instead, ... And this is a glimpse into an alternate reality, okay? Which actually, it's just a silly way of saying this is another way to end this question and still be correct. So if we had chosen this, it would have been y minus y sub 1 equals m times x minus x sub 1. Now, just like before, you need all 3 components. You need this, the slope, you need your y number, you need your x number. Now we have the slope, and that is not going to be different because we're talking about the same line. So I will have -5 over 4 right there. And you know what, just to make my point from earlier, I'll move that negative down here, 5 over -4. Now for my x and y, because we're going with a different ordered pair, this is now my x, this is now my y. And so those numbers belong into these spots, and it goes like this. So it's y minus, my y number this time is a 2, and so it's y minus 2. My x value, however, is a -3. So I need to show that what I'm substituting is a negative number. So it's x minus the -3. And notice that I end up with parentheses and side parentheses. That just helps to create spaces in my head so I can see what needs to happen with those 2 negatives. So they become a positive sign. And so I rewrite it and finish it up with y minus 2 is equal to 5 over negative 4 times x plus 3. And with that, we are done. Okay? So you can see that these two functions in the end don't look the same except for the slope. However, they both are the function of this single line you see here. So I hope this video helped you out. Please check out my video before this with examples 1 through 3. And as always, please stop by, leave a comment, leave a post, and I will see you again next time. Take care. Bye.